Hello everyone. Today we are going to start the series of organic chemistry for class 12. Haloalkane and haloarenes will be the first chapter in the series. And I believe that most of the children, though they understand or they try to understand, but still there is certain complexity where they fail to do what they are required to do according to board or maybe according to the competitive examination, because competitive examination also in those examination NCRT plays a very important role. So I'll be trying to demystify this NCRT book and taking it up with greater detail, and very small and easy steps we'll be taking towards it. So let's start. Hello Alkane and hello Erin. Today the first episode of the series would be about classification of hello Alkane and hello Erin. Also, dear friends, do let me know if you would like to do this video sessions or the recordings in totally English, or it is fine if I do it in bilingual. Whatever is feasible, do let me know in the comment section. Whatever is feasible to you, we'll be moving ahead with the same thing. Right? So today's video would be English only, and then we'll be doing whatever suits you and your demands. So first type of classification is based upon the number of halogen atom a carbon atom has, or a alkane chain has, or a aromatic compound has. Number of halogen atom means whether it has one halogen atom, two halogen atom, or there are many halogen atoms present in the compound. They can be named accordingly. For example, if there is one chlorine atom or any of the halogen atom like fluorine, chlorine, bromine, or iodine, any of it, then if it is one, we call it mono-substituted compound. If they are two, we call it di-substituted compound. And if there are many, we call it polysubstituted compound. Let's Now, monochloro compound may also be classified according to the hybridization of carbon to which the halogen is bonded. There are many times children in class 11th do not understand what hybridization is. I do understand that, in class 11, many of you do not focus towards your studies, which is why you miss on this topic, a very important topic of hybridization. We'll quickly and very in a very short manner, and in a very I will be explaining you in quite a detail in very small time what is hybridization. Now, hybridization in carbons may be of sp3 type, may be of sp3 type, sp2 type, and sp type. Children, always remember when there is a carbon and there is a single bond all around, we come to know, we understand that it is sp3 hybridized. Whenever there is a carbon and there is a double bond around it, anywhere around it towards the back or in the forward direction, we understand that it is sp2 hybridization, and when there is a triple bond around carbon, we call it sp hybridization. Now, looking further, we'll classify these compounds in accordance to what kind of hybridization it has. For example, in the first case, we'll understand that when carbon is sp3 hybridized, what kind of, how do we represent it, how do we name it, or how do we classify it. But before moving ahead with sp3 hybridization carbon, I'll also let you know what primary carbons are, secondary carbons are, and tertiary carbons are. Now, first of all, look at this carbon which is highlighted in pink color, right? This one, this carbon in the center. This is all around there is single bond. So can we assume that this is sp3 hybridized carbon? This carbon again, the middle one, is having single bond all around. Therefore, it is sp3 hybridization once again. And this carbon is also surrounded by single bonds all around. Therefore, I'll call it a sp3 hybridized carbon once again. Now, in this carbon, we see that carbon to which this halogen is attached is surrounded by only one R. Yeah, this thing also, I think I should take it up. What is R in this case? R is any alkyl chain or maybe group, right? For example, if it is CH3, it is called methyl. If it is C2H5, I'll call it ethyl. C3H7, I'll call it propyl. So whatever is the alkyl chain, the small version of it, the shorter form of it is written as R. This R may be different from this R, which is why they have written R dash and R double dash. This may be different from this, which is why they have written as R triple dash, right? This R is different from this R, this and this R. Therefore, they have represented by different denotions R dash, R double dash, and R triple dash. Coming back to the topic, primary, secondary, and tertiary. Primary, you can see that this carbon, the middle carbon, which is this carbon which I am highlighting, is surrounded by only one carbon chain, right? Rest of them are hydrogens. Therefore, I will call it a primary or a 1-degree carbon. This carbon in the middle is surrounded by two carbon chains and one hydrogen. I'll call it a secondary carbon, and we are talking about the carbon to which halogen is attached, right? So this carbon, the middle carbon, which is attached to halogen, is surrounded by three carbon chains, which is why I call it a tertiary carbon atom, right? Now, depending upon the kind of hybridization we just saw, this is again a sp3 hybridized carbon. We are talking about this carbon, which I have made it red. You can see that it is surrounded by this carbon on one side, and rest of them are hydrogen. We know that carbon has a valency of 4. So this red colored carbon, which I have highlighted, let me focus it here. There are two hydrogen atoms, and this is X, which they have written using a green color. I'm also using the same color. And then they have used this carbon, which is bonded to a double bond, and whatever might be here, we are not bothered about it. So if we talk about hybridization in this case, this would be sp2 hybridized carbon, and this would be sp3 hybridized carbon. You see that the carbon to which X is attached, or the carbon to which halogen is attached, is sp3 hybridized, but the neighboring carbon is sp2 hybridized. Why this is sp2 hybridized? Once again, let me tell you. This is sp2 hybridized because it has a double bond on the back side of it, which we can easily see. So this carbon, such type of compounds are known as allylic halides. So let me repeat what allyls are, allylic compounds are, or allylic halides are. Allylic halides are the halides in which carbon is attached to the halogen, and this carbon is sp3 hybridized. Because how do we know this? Because it is surrounded by single bonds all around, but its adjacent carbon is sp2 hybridized. Similarly, if we talk about this compound, let me change the color so that you can make it more distinctly what I'm talking about. Let me talk about this compound. This compound is all these are C's, right? C, 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 and C. This is 1, 2, 3, and 4th valency is satisfied by one of the hydrogen. This carbon 1, 2, and 3, 4, 1, 2, and 3, 4, 1, 2, and 3, 4, 1, 2, 3, and only one H would be required. So this carbon, because it is surrounded by the single bonds all around, this carbon is sp3 hybridized. But what about its neighbor? Its adjacent neighbor, this carbon, it's adjacent, just close to it, the carbon which is present just close to it is sp2 hybridized. So the carbon which is adjacent to sp2 hybridized carbon are known as allylic halides. Hopefully this is clear. In case you want more examples, just let me know in the comments section. Now we come to another term which is known as benzylic halide. There are people, there are children, I've seen with so many years of experience, I've seen that children write benzylic compounds very wrong. let me tell you, children, that benzene, which has one C at any of the position of this benzene, is known as benzylic compound, right? So this is C, H2, and X. So therefore, this is a 1 degree, but it's adjacent. This carbon is 1 degree, which means it is sp3 hybridized, but its adjacent carbon is sp2 hybridized, which is why this is again a allylic halide, right? Similarly here, if we see this carbon to which this halogen green colored X is attached is sp3 hybridized because it is single bonded all around, but its adjacent carbon is sp2 hybridized. Therefore, I'll call it a allylic halide. Hopefully I'm clear with this, and do let me know in the comment section if you want more examples to be done about this. Now, let us do about, by now I think everybody is clear with what is sp3 hybridization in carbon. Then we'll quickly look at sp2 hybridized carbon and to which the halogen is attached. Now, the first class of this compound is vinylic halide. What are vinyls? This is a carbon. Let us take a quick review of what vinyls are. This is carbon, this is also carbon. There is a double bond between this carbon and both these carbons, and to it this X is attached. Yani ki it is attached to the carbon which is sp2 hybridized. As I just told you that sp2 hybridized carbon is one which is doubly bonded, right? So whenever sp2 hybridized carbon has a halogen with it, we call it a vinylic halide. Similarly, if you see here, this carbon has a halogen attached to it and it is doubly bonded. That means this carbon is sp2 hybridized, and therefore I'll call it a vinylic halide. Thank you. Bye bye. Have a great day ahead.